All right, so here we are up to number 12. If we take a look at number 12, it says, what is the equation represented by the graph? If we kind of sneak a peek down here, we got tangent, cotangent, tangent, cotangent. So if we start right away and we ask ourselves, what does tangent kind of sort of look like? We would recall that it looks something like this. Now these are not perfect. Cotangent, remember, looks more like that. And so we could look at this and go, well, which does this generally reflect? Well, not cotangent, so we can get rid of cotangents, so we're down to 50% shot if we just guess. But we can do better than that if we take advantage of our graphing calculators or Desmos.com. So if we just type this in by going 0.5 tangent x, we would notice, if you took a good look, that its x-intercepts match these x-intercepts. Now there's more going on, but if we're going to simplify this a little bit, if we just type this in, tangent of 0.5x, we would notice it's missing this x-intercept, it's missing that x-intercept. The very next one, it's got this one, but then the very next one would be way out to 2 pi, and we would say, well, that can't be true. This one can't be, because this one has x-intercepts at these little moments, which reflects letter A. So I'm going to call that a Desmos.com special. Number 13. What is cosine of theta if sine of theta is -8/10 and theta's in the third quadrant? Well, we've got to do ourselves a solid, draw ourselves a picture. Quadrant 1, no. Quadrant 2, no. Quadrant 4, no. We got to draw this picture in the third quadrant. So my opposite needs to be -8. My hypotenuse needs to be 10. Now some of you are like, well, why don't you reduce it? Well, if you notice the answers, they're not reduced, so we're not going to reduce this. So to kind of sort of get a halfway decent drawing, there's my reference angle, this theta. My opposite is -8, and my hypotenuse is 10. Now to find x, you might use a couple strategies. You could notice that basically a 3, 4, 5 triangle times 2 gives us our 6, 8, 10. So we could know right away that x is just 6, but it has to be -6, just based on our 3, 4, 5 families. If you don't like that technique, you could go a squared plus b squared equals c squared. So we have 100 minus 64 is 36. So we take the square root and we'd get 6. One way or another, you'd get 6, hopefully. But it has to be negative. So cosine is adjacent over hypotenuse, which is -6 over 10. So we're looking for this. Where is it? Letter A. All right, little life application problem for number 14. A car, in other words, the container you're in, on a Ferris wheel with a radius of 20 feet. So I've already drawn that picture. So you've got this big old Ferris wheel that's going around and around and around. To the nearest foot, how far does the car travel over an angle of pi/3 radians? Well, remember, we've got to convert that to degrees. I'm just going to take that pi, convert it to 180, divide by 3. That's 60 degrees. Now, what we're going to do is we're going to calculate the entire circumference using circumference equals 2 pi r. So that's 2 times 3.14 times r, which is 20. Get out my handy dandy calculator here. Clear that out. 2 times 3.14 times 20. 125.6. So 125.6 feet is the entire circumference. That's from point A all the way back around to point A. Now that's 360 degrees. We don't want that. We want a 60-degree revolution. So we take the 60-degree revolution, divide it by 360, and that reduces to 1/6. So we only want 1/6 of the entire circumference. So we're going to multiply this 125.6 times 1/6, and that will tell us the distance. So times 1 divided by 6, 20.93. Now it says to the nearest foot, so we're going to round that up. So it's approximately 21 feet. And there we go, number 14, done. Number 15, what is the frequency, which has to do with the word period, which has to do with the formula 2 pi all over the absolute value of b. So really our job is to find b. Now remember, this has to be a, and this 1/2 must be b. So we put our normal period, or our frequency of any sine or cosine, it just happens to be in the formula, all over this b 1/2. Now what do you do when you divide by a fraction? You multiply by the fraction's reciprocal, so it's really 2 over 1, which would be 4 pi. So there's our new frequency. Now if they asked you to talk about it, you would say that your original period was doubled. But if they say, what is the frequency, then you'd say 4 pi. So you have to kind of learn how to talk the talk based on how the question's asked. All right, so here we go, number 16. Going to do this without the graph. So this is saying, right here, what is the average rate of change? So we're talking about slope of the function, diddle-a-duh. So this is saying let x equals 0. So we're going to figure out 0y by just plugging in x equals 0 right here. Well, 1/2 times 0 is 0. I'm going to just ignore this 2 for a minute, and I'm going to find sine of 0. So sine of 0 degrees is 0. 0 times 2 is 0. So my first point is 0, 0. Call that x1, y1. Now we're going to let x equal pi. So we're going to stick in pi. We're going to figure out y. Here's going to be our x2, y2. So we put pi in there. We get pi over 2. 1/2 times pi is pi over 2, which is 90. So I'm going to type in sine of 90. And I'm going to get 1. 1 times 2 is 2. Now I'm going to take these values and I'm going to stuff them in. Let's see if I'm still on the screen. Yes. y2 minus y1. x2 minus x1. y2 is 2. y1 is 0, x2 is pi, minus x1 is 0, so I get 2 over pi. Go on the hunt. There it is, letter D. Okay, so number 17 gives you a multiple choice. It's a very easy problem if you just stumble on the right answer, but to really do a multiple choice question right, we got to know why the wrong answers are wrong. So let's take a little look here. I've already typed in, let's see here. Let's go, all right. Let's go to my graph. I've already typed in y equals tangent of x, and I'm going to hit graph, and we're going to take a little look at it before it goes dark on us. So, which of the following statements about the graph of y equals tangent of x, I've got it right here. You could go to decimals if you want, but it says the period is 2 pi. But remember, the period is from negative pi over 2 to pi over 2, because those are our asymptotes. So that period is only pi. So we can eliminate that. The function has horizontal asymptotes. See, we should know right away that that's not true, because all of our asymptotes are vertical. You can see that that is true. So there's no horizontal asymptotes. The function has zeros whenever cosecant equals 0. Now this one's kind of interesting. If cosecant is equal to 0, we have to remember cosecant is the reciprocal of sine. So sine is opposite over hypotenuse. How in the world could cosecant equal 0? Well, that would mean we'd flip sine, hypotenuse over opposite. That would mean our opposite would need to be a 0, meaning it has no length, and that is not possible. We have to have a hypotenuse in order to have trig. So that's a sneaky little question. So by process of elimination, we can see that it must be D. But it's saying the function is increasing everywhere. So let me regraph this. increasing everywhere means as we move left to right, our drawing is always going up. And you can see no matter where I put my roller coaster, if I go left to right, I'm going up. I'm going up. So there's my correct answer, letter D. Okay, number 18. When the sun, my little art there, shines at a 60-degree angle to the ground, meaning that angle right there, although it doesn't look like it, is 60 degrees. Talisa's shadow is 36 inches long. Now let's make sure we understand something. This would be her shadow right there. So what I'm going to do, it says to the nearest inch, how tall is Talisa? I'm going to take this triangle right here, because that's really what they're asking about. They want to know how tall she is. And I'm going to draw this out just a little bit bigger, a little bit better, 60 degrees. Her shadow's 36 inches, and they want this. Well, if this is my reference angle, this is my opposite side. This is my adjacent side. So I'm going to use tangent. So tangent of 60 degrees equals her height over her shadow. And now I'm going to take my calculator, and I'm going to go tangent, tangent of 60 degrees. And I'm going to, remember, I got to multiply both sides by 36, so those cancel. And 36, so I'm going to go times 36. I get 11.52. 11.52. Okay, that's kind of strange. Something's wrong with this problem because she has a height of 11.52 inches because everything's in terms of inches. So maybe the shadow was longer, but anyways, for time purposes, we're just going to call her 11.52 inches. Okay, last problem, you guys. All right, so I worked a little bit ahead, but 19. Here we go. The graph of f is given below. So there it is. Now let's talk about the graph of f. What do we see? Well, we can see that the amplitude is 2. So it's 2 up above the x-axis. It's also 2 below. Now, if we looked up at letter G, we would say, hey, the amplitude of letter G is also 2. Based on our formula, the absolute value of A, which would just be the absolute value of 2, which is just 2. So we can see there's no difference in the amplitude. So we could get rid of these options that say that their amplitudes are different. They're not. They're the same. So it's going to boil down to the frequency or the period. Now if you take a look at this graph, letter F, if you take a really good look, I'm going to pick out this chunk right here and talk about the period. You can see that the period is from -2 to 2, so the period is 4. So we're going to do a little reverse thinking here. If the period of f is 4, then we know that this formula for the period has to equal 4. So we got to do a little reverse thinking here. What could we put in there to create a 4? Well, if we wanted to, we could say, all right, let's make this a purely math problem. We're going to take the absolute values off, assuming that b is going to be positive. And then we're just going to go ahead and solve it like a math problem. we got to figure out what b is. So we're going to multiply that side by b so it cancels. Multiply that side by b so we get 4b equals 2 pi. Divide by 4, divide by 4, and we'd get b equals, if we reduce that, we'd get pi over 2. Which would make sense because if we took a look at this and we went 2 pi all over pi over 2, we would multiply by 2 over pi. Remember, you multiply by the reciprocal, and these would cancel, and we'd end up with the period being 2 times 2, which is 4, which is what we want. So in this problem, we know the period, or the frequency, is 4. So what about the period for this one, number 19? Well, we see that b is pi. So for g of x, we're going to figure out the period by going 2 pi over the absolute value of b, which is 2 pi all over the b, which is pi. I'm not showing my work very well. And so we've got this formula here. So we have to put that in for b, the pi. So So we're going to put that right in there, and it's going to tell us that these cancel, so the period is 2. So the period of g of x is 2. The period of f of x is 4. You can see that this is twice this, or this is half this. So let's see which one says it. The period of f is half as long as g. The period of f is twice as long as g. We can see that letter B is correct. It's a tricky little problem, but let me know if you have questions. Good luck on your studies.